Okay, thank you. Good catch. Okay, so here we are. We're recording. Where we talked off before was arrays or objects. So the good thing about arrays, if we were just trying to track these three strings in one object, we have a class words. Every words object has three strings named A, B, and C. We're holding the same data as an array of size 3 that contains three strings, right? Same kind of data we're holding. The big difference between the two is if I want to change the contents of this words class, if I want to allow it to hold more strings, I have to create an entirely new class, which I generally cannot do within the confines of Java while a program is running, right? I'd have to stop the application, make a new class, then restart the program, which is not something you want to do, in a live application. But with an array, if I want to resize it, even though arrays are immutable, I can still use this words reference to point to a new location in memory. So I can resize it without having to call words something new. I still have to relocate it to a new place in memory, which Java is going to do automatically for me, but then I can reuse the words reference. So that's the big difference between the two. The other thing, all of those initial objects, right, the strings in words or the strings in the array words, when I first create the container for them, they're all going to be null, right? If I just have a words object, if I haven't created the individual strings within that words object, the strings are going to be null. Likewise, when I create this string array lowercase w words, I'm only creating the file cabinet. I haven't created the individual strings that are going to occupy the three drawers of the file cabinet. So in both cases, they're going to be null. Okay. Anyway, the rest of this lecture will be about indexing and resizing arrays. So indexing in arrays works just the same way as accessing individual chars in a string. So the first element in an array has index 0. Last index in an n element array is n-1. So just like we saw with strings before, indexing starts at 0. Unlike strings, an array has a length attribute. So you access it directly by just reading its length. So what I have here, words.length, right? I'll box that in red. Damn you. Okay, so let's box that in red. Unlike for a string, right? With strings, I access it through the length method call, right? Because the length attribute for strings is going to be private. You can't read it directly. So again, for strings, I read the length attribute by calling a method. For arrays, I can just access the attribute directly. So that's something you'll want to watch for when you're trying to debug your code. It's a common early mistake. Okay. Now I'm going to get rid of this. Okay. Starting loops at 0 to initialize arrays is a very common way to do it. So imagine if I have a new array containing 1,000 words. I might start with a loop starting at index 0, proceed while loop is less than words.length, add 1 after each iteration, and maybe assign to each element of that array an empty string. Okay, I could do that, just so I don't get these sort of null string errors. Okay, you can also change array elements. So with an array of primitives, remember, primitives are going to occupy the same space in memory regardless. So that's a key difference in how this works. So remember that all primitives have a known data size, right? So example, bytes, 1 byte, up to ints, 4 bytes, doubles, 8 bytes. Okay, and they all have their known data size. The difference is, right, so if I have an array of primitives, I know based on the array size how much memory is required. So I can change those array elements in place, right? I don't need to create a new object somewhere to do it. That's not going to be a problem. However, if I have an array of objects, I might not know their exact size. Okay? For example, a string could be very short or very long. Okay, this is a problem. So how do I handle this in memory? Well, the short version is I can rewrite them the same way. Basically, when a new object is created, is overwritten, right? When it exists, when an element of an object array is overwritten, Java will create that new object somewhere else, but still use the array reference to point to it. Okay, so what happens? Imagine if I have a box of memory somewhere. This is my little box of memory. And over here, I have an int. And over here, I have string 1 and string 2, and let's label those. Okay. S1, and you can be S2. Okay. And suppose I have an array of type int called nums and a type string called words. Okay, so if I say something like, for example, nums 0 equals 6, right, and then I overwrite that to nums 0 equals 7, all I have to do with that is change the value at this point in memory, right? I never have to change what this reference points to. However, if I'm doing it with strings, strings are going to work a little different, right? If I say words 0 equals hey, okay, maybe that points down to this string. Okay, but if I do overwrite that with words 0 equals you, okay, even though they're the same length, Java is not going to track it that closely to say, oh, can I fit this in the same space? It's just going to create a new spot in memory where that string is stored, and it's going to point to that. So with simple primitives, if I overwrite them, the data just gets overwritten in place because I know what the exact size is going to be. But if I'm talking about objects, I still get to keep the same reference, but the reference is what's actually stored in the array, and the reference points to some memory location. So that changes. So I still use the same structure. Word 0 is still going to point to some place in memory, and I can still reference either hey or you through this word 0 reference, but they're going to point to different places in memory. Okay. All right, so again, anytime you change an object or a data value in an array, the array structure is going to be unchanged. This is different from other kinds. Some languages, for example, like JavaScript, allow a lot more flexibility in how you change the size of arrays. For example, if you add a new array element to an index that doesn't exist yet, JavaScript will generally pack it in at that available index and extend the array to that space. Java doesn't work like that. Java, you get errors for that. And if you remove an element from an array, for example, you have a string in the middle of your array, you make it null. Again, some languages or some of these collection classes you will see will automatically compress the array, but the basic arrays will not do that. So just think of it as a filing cabinet. If you have a big filing cabinet of 1 million drawers and you randomly pick one of the drawers, shake whatever's in it out all over the floor so it's empty, put the drawer back in, you're not going to affect any of the contents of the other drawers. And you're going to have an empty drawer that you just put back in. So the file cabinet analogy holds for that. Okay, so if you change something in an array, if you change one element in an array, it's not going to change any of the other elements. Okay. Now, where things get tricky is if you're doing something that changes the size. So first of all, if you delete an object, right, that's going to leave some kind of null entry in the array. Again, if you have a very large array and you're constantly deleting objects and adding new ones, but you never take time to compress the array, eventually you'll have a great big Swiss cheesy kind of array with lots of gaps in it. And scanning through that array is going to take a lot of extra time. All the code you run around that is going to be slow and sludgy because you're going to be doing a lot of tests on array elements that are blank. So periodically, you want to resize the array. So if you have a large array that you're periodically eliminating elements from, yeah, once in a while you want to compress that. Or on the other hand, if you have an array that is getting bigger, right, that you initially created the array with 1,000 elements, but as your program runs, you need to store more than 1,000 elements, you have a need to resize it and make it bigger. Okay, so what we'll see, an example of that in just a moment. So just like strings, arrays are immutable, cannot be expanded or compressed in place. But they're objects, so they can reuse references with the equals operator. So the way it's going to work when we resize an array, okay, fundamentally will work like this. So I have an array, dun, 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 and I want to resize it. So I'm going to make it like a file cabinet. And I want to resize it to something new like this, right? Some bigger array can hold more elements. Okay, what I would fundamentally do is this. So suppose they're all of type string. So string array S equals new array, new string. Maybe this one is size 6. Okay, so I made this string array called 6. Now, to make a new one, I make a new array called S2 is a new string array of S dot length times 2. Okay, so that's how I know it's bigger. Okay, so I have one array, this one is going to be bigger. Well, how do I transfer? Well, first of all, okay, first loop through S and copy all elements to the same indexes in S2. Then assign S with S2. So I just say S equals S2. And that's it, right? And I have suddenly made a new, much larger array. Basically, I take all of these elements here, copy them over, and then they're still there. That's fine. So we do this in Java, make a very, in Eclipse, make a very simple program here. So I'll call it string copy or array copy. Array resize. Yeah, let's do array resize. That's good. Okay. So imagine if I have an array. Okay, it's have an array of type, let's say type int. Okay, and anytime I start this program, I have this constructor method. Okay, so I'll say initialize the array to 100 elements. And because this is a data member, will be initialized to 0. Okay, so that's automatic and I don't have to do anything for that. Now suppose I want to resize it. Well, I make a resize method. Suppose I want to make it bigger. Okay, so we're going to do that. So array resize AR equals new array resize. Okay, and then AR dot bigger. Okay, so my bigger method, void bigger, I'll say bigger will double the size of the array X. Okay, so how do I do this? Well, again, first I'm going to create a larger copy of X. So int array x2 equals new int x dot length times 2. Okay, so x2 is an array of ints twice as big as x. Second step, copy all elements from X into the same indexes in X2. Okay, so 4 int I equals 0, I is less than X dot length, I plus plus, and I'm just going to say X2 at I equals X at I. Okay, so because this is a single statement, I don't need to include squiggly brackets in the for loop. Okay, and then all I have to do is just update the X reference. So I just say X equals X2. And again, with objects, I'm saying X is X2 at this point. Not that it's going to somehow equal it or contain the stuff. It's X used to point to one point, X used to point to one place in memory that stored the initial X array. Now I'm saying X points to a different place in memory that holds the X2 array. Okay, so I can test this and do system.out.println initial size plus x dot ar dot x dot length. Okay, and then I can do the same thing. I can do bigger size and then print out its length. So let's run this. We'll verify that it all works correctly. Ta-da! Initial size is 100, bigger size is 200. Okay, questions about this? Does this all make sense? I hope it does. This is how you make an array bigger. Any questions? Now, even if you use the collection classes that I'll mention towards the end of the lecture, even if you use those, deep down in the guts of Java, this is what they do. So there are collection classes where all of this type of array resizing is automated and you don't have to worry about it. But still, it does this sort of thing. Okay. I should also mention that if you want your code to run fast, it's better to do some of these operations yourself in your own code rather than going through those collections classes. They tend to be a little bit slower, although they're also easier to work with, so sometimes that's a consideration. Okay, well, moving on then. So this is an increment example. It basically does the same thing, but it makes it one bigger. Next one, compression. Okay, so we'll talk about compression, and I think then we'll call it a day for today. So compression after deletion. Sometimes you have an array, you want to delete an element in it. Okay, so suppose we have an array of ints, and we're going to delete something at index X. Okay, what we're going to do then, okay, so imagine this is our array. We're going to make some lines. Just copy that. I could probably just copy those. Dun, dun, dun. Close enough. Get rid of you, stub. Get rid of you. Okay, so this is my array, and we're going to mark up the indexes. So 0, whoop. Whoa, I didn't want to do that either. 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so suppose I want to delete whatever is at index 4. Okay, so I'm going to shuffle that in. All right, so I know the initial length. Okay, so we will delete index 4 and then compress the array so it has no gaps. Okay, so we're going to delete whatever's at index 4, we're going to delete, and then these others we're going to all move one index less. So first of all, the new array will have one fewer element. Okay, one less. I'm getting that whole less versus fewer thing. one fewer element than the original. Okay, so we know that. So the new length of it is going to be something like int x2 equals new int x dot length minus 1, right? Assuming the initial array is x, like it was in our previous example. Then what else is going to happen? Well, let's copy all this. So first of all, we're going to fill that, boom, that's white. This part is going to go away, right? Index 7 is just not going to be around anymore. Bye-bye. So all of these initial, right, pairs, these are all going to point to the same spots. These are all going to point to one less, right? So copy these to same index. Copy these to index minus 1. Okay. Then the other question is where we start. So for each of these, all right, so suppose the index to be deleted is, I don't know, let's call it D. Okay, so our first loop copies everything from 0 to D minus, right, D minus 1. So if we are skipping index 0, then we're just not going to do anything at all, right? We'll already be there. But otherwise, if we're doing something like 4, we're doing everything from 0 to 3. The second loop will copy everything from D plus 1 to x dot length minus 1. Okay, so up until the end of the array. So the next loop will start at D plus 1, and it'll continue as long as our index is less than x dot length, right? So it'll continue until x dot length minus 1. So that's basically going to be our loop. And then we do the same thing where we borrow the reference, where we reuse the reference. So let's put that in here. We'll make a smaller method, smaller, and we'll say this method will have the size of the array x. Okay, so some of this is going to be the same. I'm just going to copy some of this because a surprising amount of it will still be the same. Shift that left a couple times. Okay, so first we need to make a new array, but instead of being the array length times 2, it's going to be the array length divided by 2. Okay, we got a chat bomb here. Let's see. Shift tab also works. Oh, okay. Thank you. Okay. Yeah, they don't have a thing for it. I guess I never bothered to look around for if there was a shortcut. Okay. So int x 2, new int x dot length divided by 2. Second, we're going to copy stuff, but we need to do 2 loops for that. So first loop, okay. The other thing we need to get along is, well, this is smaller, so this is fine. We don't have to delete something in place yet. Smaller copy of x. We assume that we're going to do this. All right, well, this will actually work. This is fine, but it doesn't make sense. We're going to do the same thing I did before. I'm apparently a little spacey today. Delete an element at index I from x. Okay. Then compress the array x. We're going to do that. I don't know what I'm thinking here. So x dot length minus 1. I got caught up in having the array. So our new smaller array is going to have 1 fewer element. Our first loop is going to copy all of the elements before I, all right? Let's do the index del for delete. Okay, so we're going to accept that as a parameter. So int del, that is the index we're deleting from. Okay, so as long as we start at 0. As long as I is less than del, we're going to copy the things over. So we're going to say this from elements before del from x into the same index as an x2. Great. Then the second loop, copy all elements following, right, after del from x into index -1 in x2. Okay. So for that, similar thing, and we're going to start off with this being del plus 1, okay? We're going to continue as long as I is less than x dot length, because that's where we're copying from, and then I is going to get incremented after each one. And for all of these, we're going to do x2 at I minus 1, right, equals x at I. So for every element in x, we're going to copy it into a lower index. We're copying from index I into index I minus 1. Okay, and then at the end, we just update the x reference again. So what I can do here, this is going to just delete a particular index. So for example, I might do a test value here. So I might say ar.x, let's say at index 100 equals 1, and ar.x at index 101 equals 2. And then I'm going to call the, what did I call that method name? Smaller, okay? ar.smaller, and I'm going to delete the contents at index 100, okay? So here, assign a couple values to the array, and then delete the element at index 100 and compress the array. So at that point afterward, ar.x at 100 should hold 2, right? Because from the next higher index, that's where that should be. So we'll see how this works. And then we'll also do a smaller size. Okay. Display smaller size. And the array size at that point should be 199. Okay. So let's run it. Let's see that it works more or less correctly. Aha. So there it is, but I didn't print out the values. So let's do that. That's what I wanted to do. Okay, and I can run that. And the value at index 100 is 2. Okay, so this is how you resize arrays in Java. Again, if you want to make it bigger, you just create a new array that's however much bigger you want it, copy the old elements into the new array, and then update the reference for the array. If you want to do something, copy into a smaller array. For example, if you're going through your array and deleting elements, then you can compress it like this. Now, I'll mention one thing. In practice, if you have a large array, you don't want to be in the process of constantly growing or shrinking the array one element at a time. So in practice, what you would probably do for a large array is you would make an array that's about twice as big as you figure you're going to need. As long as the array doesn't exceed that twice size, you're fine. If it ever does exceed that twice size, at that point, then you make it maybe twice again as big as it needs to be at that moment. And so you don't very often have to change the array. Because if you're running a live application and it needs to be on and available all the time, you don't want to have your servers spending all their time just spinning around and updating this array for every tiny little thing that happens, right? You just say, yeah, I'm going to make this work in a reasonable amount of memory. I'm not going to create a borderline infinitely sized array. But on the other hand, I'm not going to try to perfectly size it either. This sort of thing is one of the reasons why applications that have a lot of spare memory available tend to run faster, because they don't need to constantly update their arrays to perfectly optimize memory usage. All right, questions on any of this? Does this all make sense? So what are the big things we covered today? Well, we talked a little bit about arrays that was more like a refresher from Monday. And then we talked about resizing them. So because arrays are immutable, you can't just make it a new size. Instead, you have to create a new array of the appropriate size you want, okay, which is a bit of a hassle, but it's a lot less of a hassle than having to write a complete, shut down your application, write a new class, compile all that, and relaunch the program, which is what you would need to do otherwise. Okay, questions on any of this? Are we all good? We good enough? I'm going to stop sharing, and I guess I'm going to stop recording.